In previous modules, we learned how satellite data can be used for different types of climate applications. This is great resources for climate research. But how do you know how good are those satellite data for climate applications? In the final module on the topic of remote sensing, we will learn how can we evaluate the remote sensing data to make sure that they are suitable for climate applications. To ensure satellite data is accurate and can be used for various applications, we often need to verify against certain reference data. The verification typically has a few different components. First of all, is to ensure sensor data is of high quality for downstream applications. This often requires calibrating the sensor data regularly against a stable and robust target. Sometimes this target can be a large desert areas, ocean, or lunar surface. Once the sensor data is validated, we will need to evaluate the algorithms used to retrieve those physical parameters, such as temperature or precipitation, as well as the vegetation dynamics that we have used in the past tutorials. This is trying to make sure the retrieval is of high accuracy for climate applications. The last step is often to ensure the data is consistent across different satellite platforms over a long period for climate applications. That's what we call intersatellite calibration and how to evaluate intersatellite calibration. This consistency evaluation is important to make sure that the signal we see in satellite data is not caused by the artifacts in the satellite data and is a real signal from climate change. The verification or evaluation of satellite data often needs to use measurements from in situ. In situ measurements can be observations from land-based stations or data collected by a buoy, ship, drifter, or other platforms that take direct measurements of the targets over the same areas. Sometimes we can also use data collected by airplanes and drones as a reference to evaluate satellite data. As shown in the figure before, satellite data evaluation often requires the matching between satellite data and reference data, both spatially and temporally. The matching is trying to make sure that they are measuring the same target at a similar time, without much difference occurred during those observation times. The matched up data between the satellites and the reference data can then be used to form a quantitative evaluation to calculate such as the bias of the satellite data and how it compares to the reference data, the precision of the measurements from the satellites, and the correlation between satellite and reference data. Those quantitative metrics can give us a confidence and information about how good satellite data is and whether that can be used for different type of applications, including climate application. When we are comparing the data pairs between satellite data and reference data, we often plot them into a scatter plot. During the scatter plot plotting, we often want the matchup data points to be as close to the 1-1 line in the scatter plot as possible, which indicates that satellite data is closely related to the reference data. This close correlation between satellite data and reference data usually means that the data is of high quality and can be used for various applications. In this tutorial, you will learn how to evaluate satellite data by comparing the GPCP monthly precipitation climate data records from NOAA with observation-based climate precipitation data, which is gridded observation of both temperature and precipitation called Unclimb Grid Monthly. The example also, when comparing the two datasets in the tutorial, you will also learn how to convert the total precipitation data to precipitation rates. That's trying to make sure the comparisons are performed on the same physical parameter. This is also important information to ensure during the comparison and evaluation process.